I wanted to see if Claude Code could genuinely reverse engineer a backend project. Not just describe what a few files do, but actually build a mental model of the whole system. Architecture, database design, security, API structure, and everything. What I want to show you in this video is a different way of thinking about prompts entirely. Not what to ask, but how to engineer the ask. Here is what most developers do when they want AI to understand something complex. They just write, explain this, and hope for the best. And what they get back is a summary. Broad, surface level, confident sounding, and often missing the parts that actually matters. And most of the time the output is fine. But fine is not the same as deep. Fine is not same as accurate, and fine is definitely not same as useful when the task actually matters. So here is what I did. I gave Claude Code my entire backend code base and asked it to reverse engineer the whole thing. Honestly, it was more thorough than the most handwritten architecture docs in real projects. The reason it worked had everything to do with the structure of the prompt. Most of the time, the problem is not the AI. The problem is that a vague input produces a vague output. The model doesn't know how deep to go, which angle to take, and what level of expertise to assume, or what the actual deliverable should look like. So it defaults to the middle path: readable, generic, and forgettable. The fix is not to ask better questions, it is to build better prompts, and there is a difference. I want to give you the 6 principles I used in the prompt because these are what you take away from this video. The backend example is just a means to do it. The first is role priming. Before you tell the AI what to do, you tell it who to be. Not analyze this, but give it a role. You are a senior backend engineer performing a deep architecture review. The role sets the cognitive lens. It changes what the model pays attention to, what it treats as a warning sign, and how much depth it goes into. The second is constraint-first. AI takes shortcuts, not because it is lazy, because it is pattern-trained. It sees something familiar and fills in the blanks from memory instead of reading what is actually in front of it. Constraint-first means you catch that before it happens. You literally write, "Do not assume anything before reading the code." And that one line stops the model from filling in the blanks through pattern recognition instead of doing the actual work. The third is sequential chaining. You break the task into ordered steps where each one builds context for the next. This is engineered reasoning. You are not asking the model to think step by step. You are designing these steps yourself in the order that makes each one more informed than the last. Think about how a good job interview is structured. You don't open with "what is your 5-year plan?" You start with background, then experience, then specific skills, then situational questions. Because each answer gives you context to make the next question smarter. If you ask the 5-year plan question first, the answer would mean nothing. Sequential chaining works the same way. You design the order of questions so that by the time you get to the hard ones, you already have everything you need to understand the answer. The fourth is output contract. You define exactly what the deliverable looks like, but you put the definition at the end of the prompt. After all these steps, this distinction matters more than most people realize, and I'll come back to it. The fifth is uncertainty valve. You explicitly give the model permission to say it doesn't know something. Without this, it fills every gap with a plausible sounding answer. With it, you get honest gaps instead of confident fabrications. And the sixth is evidence anchoring. You force the model to ground its conclusions in what it has actually read, not in what it expects to find based on patterns from its training data. So those were the 6 principles. Every single one of them applies whether you are reverse engineering a code base, analyzing a legal contract, reviewing a research paper, or auditing a product specification. These steps change, but the principles don't. Now let me show you how these 6 principles show up in the actual prompt, line by line. It opens with role injection. You are a senior backend engineer performing a deep architecture review. That is role priming in action. You are not just giving context, you are installing a judgment system. The model now filters everything through the experience of someone who has seen what good architecture looks like and knows what bad architecture cost. Next is the task definition. Your task is to build a complete mental model of the system. The phrase mental model is doing a lot of work here. It is not asking for description. It is asking for understanding. That is fundamentally different output. Then immediately the hard constraint. Do not assume anything before reading the code. This is constraint first, and this is the single most important line in the prompt. The model will pattern match by default. It will see your folder structure, recognize familiar frameworks, and produce an analysis of those frameworks rather than your specific implementation. This line shuts that down before it starts. Then process enforcement. Follow this process step by step. This is where sequential chaining kicks in. And the order of the 10 steps in this prompt is not arbitrary. Steps 1 and 2 are breadth first. Get the 30,000-foot view before you zoom in. What is this thing and how is it structured? Steps 3 and 4 go from architecture to data. You understand the skeleton before you look at what flows through it. Steps 5 and 6, security and API, only come after you know the data models. Because you cannot understand an authentication system without knowing what it is protecting. Steps 7 and 8 trace a live request through the system and map the dependencies. By this point, the model has enough context to follow that request through every layer. And steps 9 and 10 are synthesis, a diagram, a critical assessment. You cannot do this well without completing previous steps. This is the core idea behind sequential chaining. Each step is smarter than it would have been without the steps before it. Then at the very end, the output contract. Generate a document called project analysis containing project overview, etc. through 10 sections. Putting this last is the contract before execution principle. When the output format comes at the end, the model does the analysis first and then organizes it. When the output format comes at the top, the model fills sections to satisfy the structure rather than the substance. That order flip is one of the most overlooked things in prompt engineering, and it quietly ruins a lot of outputs. And finally, the clarification hook. If everything is unclear, ask questions before making assumptions. That is the uncertainty valve. It sounds minor, but it is not. It is the difference between a confident wrong answer and an honest gap you can actually work with. Every one of those 6 principles, role, constraint, sequencing, output contract, uncertainty valve, evidence anchoring, applies to any task where you need AI to go deep instead of broad. These specific steps in this prompt are backend specific. If you were doing the same thing for a front-end project, step 4 becomes state management instead of database layer. Step 6 becomes how the UI consumes APIs instead of how the API is designed. The skeleton of the prompt stays identical. You are just re-engineering the steps for the domain you are working in. That is the mental model I want you to leave with. Not here is a prompt for reverse engineering code, but here is how you architect a prompt for any complex analysis task. And here is a working example of what that looks like in practice. A few rules that apply regardless of what domain you are using this in. Do define the role before the task. Always. The role shapes how everything after it gets interpreted. Do put your constraints immediately after the role. Constraints that come late get ignored or overridden by context the model has already built. Do put the output format at the end. After all these steps, not before. Do give the model real material to work with. In this case, that means actual code, not just file names. In another domain, it means the full document, not a description of it. And do include the uncertainty valve every time. It costs you nothing and prevents confident fabrications. This prompt works because the 6 principles were applied together in the right order with nothing missing. Pull one piece out and the quality drops. The principles are a system, not a checklist. The full prompt is in the description, but more useful than the prompt itself is the thinking behind it. Role, constraint, sequencing, output contract, uncertainty valve, evidence anchoring. 6 principles, apply them to the next complex task you give an AI and see what changes. If this way of thinking about prompts was useful, like the video and subscribe, because this is the kind of thing I want to keep going deeper on. See you in the next one.